Good morning, this is Asha here. Today I am going to discuss on projection of solids, that is square prism beta angle problem. See, this is the third problem in the projection of solids. The problem is about a square prism and the dimension of the square base is 35 mm. And axis height is equal to 60 mm and it is resting on HP on one of its corners of the base. So first position we know that always it is resting on HP. So it is HP inclination with respect to HP and inclination with respect to VP. You have to see among these three problems, this problem is which one? Okay, so here it says that axis of the prism is inclined to HP at 40 degree. That satisfies the second condition. And the third position, it says that axis of the prism is inclined to VP at 30 degree. So this is the second condition, axis inclined to VP at 30 degree. So it is a beta angle problem. So first we know that it is resting on HP. So we are starting the first position below the XY line and it is resting on one of its corner. So one of the corner should come to the extreme right position. So here the corner A is the one which is resting on HP. And when viewed from the front, A1 is visible, B1 is visible, and C1 is visible. D1 and O1 will be hidden. When viewed from the top, whichever is written in blue line, that is visible. That top surface, that is ABCD is visible, whereas A1, B1, C1, D1 is hidden. The center of the top surface is O is visible, whereas O1 is hidden. So first draw the first position. Go for rectangle by 2 points. The dimension of the square is 35. So go for width 35, height 35, angle is 45 degree. Okay, it should be visible because from the top, this entire top surface is visible to me. Okay, you have to name the surfaces. So I can see A1 will be hidden. So A1. So write in small letters. A1. So this point, so A is visible, B is visible, so B1 is hidden. I can see C1 is hidden and D1 is hidden. I can see the center O, so use projection line. Connect from one corner to the opposite corner. So for me, O is visible to me, whereas O1 will be hidden. Now project, use the line option, project CB onto XY line, again A to XY line. Now when I am viewing from the front, I can see the height as well as the length. So go for visible. So from C, the height is 60. See, when I have to write the front view, the viewer will be at the bottom. I can see CC1, BB1, AA1, AA1, BB1 and CC1. DD1 will be hidden, also O and O1, which will be at the back. So I can see B, so make BB1 also visible. Now right, bottom is always C1, C1 dash. Top surface is C dash. Here B1 dash, B dash, again A1 dash and A dash. D1 dash. So write it here. D1 dash is hidden to me. Then D dash. Okay. Similarly, O dash and O1 dash will be hidden to me. O1 dash. Okay. So now show all the dimension, show the height of the prism, show the dimension of the square prism. Whatever they have mentioned numerical values, that we have to show it. So this is O dash, B dash and D dash. Again here it is O1 dash, B1 dash and D1 dash. Okay. Now the second position, the first position has been completed. The second position, he says that axis of the prism is inclined to HP at 40 degree. So even if you incline AA1 or the axis line, both are parallel to each other, both will be having the same inclination. So select the second position. So the first position, go for move option. It has to keep a copy. So move to a different location. Then go for rotate. Select A1 dash, A dash. Give the position angle as 40 degree. Okay, now show the angle. So you want to manually construct this. First, draw a 40 degree inclination line. In a compass, measure A1 dash to A dash. Mark it on the 40 degree inclination line. So you will get A1 dash and A dash. From A1 dash and A dash, draw a 90 degree inclination line. Measure A1 dash to C dash and cut it on the 90 degree inclination line. Similarly, A dash to C dash, cut it on the 90 degree inclination line. So you will get the point C1 dash and C dash. So join using visible line. Then in order to get O1 dash and O dash, measure A1 dash to O1 dash, mark it on the same 90 degree line. Again from A dash to O dash, measure it and mark it on the 90 degree line. Then join O dash to O1 dash using visible line. Then use the projection line. So start from A1 dash. A1 is here. The intersection will be A1. So use the projection line. Use projection line. So A1 dash, A1. Okay, B1 dash, B1, C1 dash C1 and D1 dash D1. Whatever extra line is there, you trim those lines. Similarly, you extend A dash with A, that is point A, B dash with B, that is point B, C dash with C, and D dash with D. Now name it. So this is A, this is B, this is C and D. Similarly, A1, B1, C1 and D1. What is the procedure for drawing visible and hidden lines? First rule, connect all the outer boundary points through visible line. So I am connecting all the outer boundary points through visible line. So use visible line here. So connect all the outer boundary points through visible line. None of the outer boundary points should be hidden or in projection line because you can see the outer edges. Okay. Then observer, if you want to write it for the top view, the observer will be at the top. The base near to the observer is A, B, C, D. So make that base as visible. Then after following these two steps, one of the points is not connected to any of the points. So that is the point A1 or the point nearest or on the XY line. So line emerging from that three edges will be hidden, provided that they are not at the outer boundary. So use A1. You can see here A1 is connected to A1 is connected to B1 and A1 is connected to D1. So these three edges will be hidden. So hidden line is represented as dotted line. But I can see C dash and C1 dash. So make that line as visible line. So C1 dash to C is visible. Only from A to C that edge will be hidden to me. Now you represent O1 and O. So this is my point O1 and this is O. Okay. So here I cannot show the projections or the axis line because first preference is for visible, then for the hidden line and then for the axis line. So second position we have completed. Third position, it says that axis of the prism is inclined to VP at 30 degree. Axis inclined to VP, it doesn't say appears, so it is a beta angle problem. Inclination with respect to VP is 30 degree. So take any parallel line. Draw a 30 degree line. Length can be anything minus 30 degree. Okay. Make this also projection line. Okay. Show the angle 30 degree. See, what is the axis? True length of the axis, that is 60 mm. So take arc by center point method. You can take any length, okay, any point, 60 mm, cut an arc. Okay, this is the locus. I'll draw once again this 30-degree line. Okay, line length can be anything, angle is minus 30. Okay, measure 60 mm, use arc by center point method, radius equal to 60 mm, cut an arc. So this is the locus. So wherever it intersect, draw the locus. Now this is the locus. So I name this as O and this as O1. Okay. Now measure O to O1 from the second position since it is a beta angle. Okay, 45.96. Use arc by center point method with the same center. Measure 45.96, that is the radius. Draw an arc. Okay, again go for arc by center point method. Measure 45.96. Cut an arc. .96 should be the radius. Draw an arc. Now join those lines wherever it has cut the locus with the same O1 and extend that till where you have drawn. Show the angle 30 degree. So now measure the angle. So measure. So this is the beta angle. Okay, 41 degree. So you can see here. So angle is 41 degree. Okay. Now select from the second position. Click on either O1 or O, preferably on O1. Wherever the intersection is there, place it exactly over there. So it has to keep a copy. So select the position from the second position, move option, it has to keep a copy. Click on O1, place it exactly on O1. Then use the rotate option. Click on O1, then O. It should not keep a copy. Rotate and place it. Okay. Now you have rotated and placed on the beta angle. Now in order to get the final projected. Use the projection line. A1 is here. So A1 will be on the XY line. So this is point A1. B1, so B1, that is the point B1. C1 projected onto C1. Then D1, so we have drawn A1, B1, C1, D1. Similarly, draw for A, B, C, D. So this is A. So this is A dash. So that is the point A. B, B dash. C, C dash. And D with D dash. Now name it. So A1. So this is point A1 dash. B1. So this is B1 dash. C1 is here. So this is C1 dash. D1, the point D1. So this is D1 dash. Similarly, A, C dash, B. So this is my point B dash. C, this is C dash, and this is D dash. Now I am writing the visible and hidden line for the front view. So go for line option. First rule, connect all the outer boundary points through visible line. So I am connecting all the outer boundary points through visible line. Then second is I am writing for the front view. Viewer will be at the bottom. Bottom surface near to observer is ABCD. So make that ABCD visible. A dash, B dash, C dash, and D dash. After doing that, one of the points is not connected to any other points. That is the point D. Line connecting from that will be hidden. So go for hidden line. Okay. So use hidden line. So A1 to D1, D1 to C1, and D1 to D. So B1 to B is visible to me. So use the visible line to connect from B1 to B. Now write the axis line, project it. So this is the point O1 dash to again from point O2. So write this. This is O1 dash and this is O dash. Okay, connect these lines through axis line. So connect from O1 to O axis line. Okay, so this is the final solution for the given problem.